Hello everyone, my name is Ella Rubtsova and I will be presenting a joint result with Professor Joosten. He works both at the Open University of the Netherlands and at the development company Ordina. The title of the paper is Enterprise Modeling with Conventions. In this talk, I am going to explain the specifics of enterprise modeling as a successor to information system modeling, current practice of enterprise modeling, tools available for enterprise modeling, new iterative process of enterprise modeling with conventions, explained with a case study, 5 iterations and conventions at different levels of abstraction. And I will finish with analysis of the proposed modeling process and future work. Enterprise modeling is a coherent combination of several modeling semantics and notations, such as goal modeling, concept modeling, business process modeling, and resource and technical components. Enterprise modeling is a successor of information system modeling, extending it with goal modeling, resources, and processes outside information systems. An enterprise model doesn't pretend to model the entire enterprise. It focuses on elements that are relevant to achieving a specific goal. Actors, concepts, information sets, business processes, technical components. The current practice of enterprise modeling is mostly drawing pictures of different views. The views are often inconsistent. Team members represent the same concept by different names, forget relations between views and elements. Enterprise architects need a modeling process that allows a team to work on different views and make them consistent. Let us see what tools are available for enterprise modeling. There is a standard of the open group called Archimate 3.1. It presents specification for all notations and semantics of enterprise modeling. There are tools for drawing views that follow this standard. For example, the Archie tool, open source, available by Philippe Beauvoir. The tools provide a palette of elements and relations for different notations, workspaces to draw views, and an underlined storage of all instances of elements and their relations in the views. The underlined storage is a structure of relations. This slide shows a fragment of this structure. The types of the elements and relations are standard types of the Archimate metamodel. As the views are drawn, this internal structure is filled, populated with elements. Each element in the enterprise model has an internal key, a unique long number. These numbers are shown on the slide. The current practice is also to draw pictures of modeling conventions without verifying them on models. The Archimate models of security, privacy regulations, design principles, and other laws can be found in literature. There are 2 prototypes of verification tools. Babkin Ponomaryov created a metamodel of the Archimate language in the Alloy tool and used the MIT Alloy Analyzer for searches of violations. Joosten Rubtsova-Hadauchi used the Ampersand tool, which generates the metamodel directly from the Archimate model and searches for violations. Both approaches are based on the calculus of relations. Having all these tools, we propose a new iterative enterprise modeling process, where views and conventions are woven together. The first step is to design views in an Archimate-based tool. The second step is to run ampersand and generate the metamodel in the file repo Archimate. The third step is to design and formalize a modeling convention in the file constraints.adl. The next step is to run ampersand to find the violations of the modeling conventions by the views. The violations appear in the file violations log. With all this information about violations, one can correct the views and repeat with another modeling convention. The ampersand compiler parses the Archimate metamodel and the conventions. Each convention is used as a checking function for all views in the populated underlying model. We have tested the proposed process on a real case study called host families. Here we present an anonymous version. We use 5 modeling iterations with 5 modeling conventions. Our goal is to create an enterprise model with clearly documented and verified conventions for represented modeling features. The host family enterprise supports the placement of international trainees with host families throughout the country. The matching of families and trainees is done by a volunteer organization. The matching points are languages spoken, disabilities, allergies, and many more. The first view shows the business process and the actors. We see the actors trainee program coordinator, and the process register and intake trainee. We see host family coordinator, and the volunteer body, and the process register host family. There are processes match, allocate, convoy, and let go. The second view shows the application services and technical components. Cloud platform with some registries, mobile devices, client nodes. With these two views, we used ampersand to generate the metamodel. At this point, the modeling convention 1 comes in. Every business process must be served by at most one microservice. If we express this convention in the first order logic, this means that the application services serving two different processes are different. In ampersand, the negation of the identity constraint expresses the difference of business processes and application services. Ampersand presentation contains also a code of the feedback in the case of violation of the convention. There is one violation, business process allocate is served by multiple services, register allocation, and intake trainee. In this figure, we see the violation. Process allocate is served by two microservices. The association allocate intake trainee has been deleted to correct this model. Enterprise architects have formulated the modeling convention 2. Every business process should be served by a microservice. In the first order logic, it's expressed with the quantifier exists. For each process, there exists an application service that is serving this process. In the ampersand, we always deal with pairs of processes and application services, so the identity constraint is used to express existence. The serving relation is shown in two directions. The response of the ampersand compiler helps to spot omissions in the microservices for processes: information session, match, register host families, register and intake prenew. We see the missing microservices for processes in the first view. Ampersand makes its assessment over all views together. It is up to architects to correct the views or make exceptions for some processes. Modeling convention 3 is about data access. If an application on one node needs to access a data object on another node, the connection has to be visualized. Some application services access only data on their own node, while other services access data on a different node. The formal expression covers all the cases. A missing connection between nodes, client nodes, and cloud platform has been found. The views have been corrected, and a view of this modeling convention has been drawn in the model. At this point, enterprise architects started to think about usability of the business process. The modeling convention 4 tells if a business role or a business actor is assigned to two subsequent process steps that are being served, this step must be realized by application services on the same node or device. One violation has been spotted. Body performs one step on the client node, and the next step he or she has to switch to mobile node. Interpreting this violation message, the architects realized that the unsubscribe microservice should run on both mobile devices and on client nodes. They also see the triggering relation between steps convoy and let go processes as a modeling error, since the unsubscribe as a host family should be triggered by the host family. So the business process has been corrected, and host family has an association with the process let go. Modeling convention 5 is to visualize the networks that connect technical nodes. It is a good reminder. Every connection requires that there is a network to connect both ends. Two violations have been spotted between the nodes cloud platform and mobile, between the nodes client nodes and cloud platform. To make other views conform to this convention, a new view of modeling convention 5 has been added to the model. Sometimes it's possible to visualize a convention, sometimes not. The process of modeling can continue. It collects the modeling conventions that have been used, and they can be analyzed. For example, our 5 conventions can be placed into 3 groups, corresponding to different goals. Conventions 1 and 2 refine the maintainability of services. Conventions 3 and 5 are about connections and data access. Convention 4 refines the usability of the application built for the business process. All of these conventions now belong to the model as its documented features. Summarizing, we may say that the research results of this work are the following. An enterprise modeling process where the documentation, formalization, and automated verification of conventions are woven into the natural process of creating model views. A set of formalized modeling conventions related to 3 generic enterprise goals, and an enterprise model with quality characteristics expressed as modeling conventions. There are cons and pros of the proposed modeling process. The cons is in that process stimulates formalization of conventions, making the process labor-intensive. On the pros, it produces models with quality stamps. Expressed as true modeling conventions, it promises to increase the correctness and completeness of enterprise models. It supports a team working within the boundaries of conventions. In the future work, we are going to use the new process in education to improve the enterprise modeling skills of students and professionals. We are going to relate modeling conventions to goals of enterprises, and we are going to explore the possibility of reusing modeling conventions. A lot has to be done, and I'm happy to answer your questions.